Welcome to Tabara Academy channel. My name is Tabara and we are going to cover a very specific topic in maths, especially for grade 9 Cambridge. So stick with me in this channel if you are a student and you are in grade 9. Remember to share and subscribe and hit the notification button and leave comments where you are watching me from and what grade are you and what topic are you struggling from in maths. We're covering about numbers and let's uncover the nature of irrational and irrational numbers. What does this all mean? Let's go. Irrational numbers. Before we go further, you can see that there is the word ratio inside the word rational. So this word ratio in mathematics, you know, it has to do with a fraction. A ratio, it means fraction. So here it means we have got irrational, which means no fraction. In other words, a rational number is a number that we can write as a decimal or as a fraction. But again, there are things which we still have to pay attention when it comes to this number. Let's split them into two parts. I'll put this one, ratio, that these are irrational numbers, the other side, rational numbers and irrational numbers. Let's go. What happens here is that rational numbers, as we said, are numbers that can be written as a fraction or as decimals. By this I mean we have this we have, for example, 2. Okay, all whole numbers are rational numbers. Why? Because 2 can be written as a fraction. We can write 2 as 2 over 1 and it's fine. Let's say, for example, -3. -3 is also part of rational numbers. It is integrated in rational numbers. So why? Because we can write -3 as -3 over 1. We have this. And we can also have 0. 0 is also a rational number. Why? Because we can have 0 over, for example, 2. It's still 0. So this is a rational number. All decimals, not only fractions, but also decimal numbers. Decimal numbers that terminate, or those numbers that can end, have got an end. We have one first, decimal, second decimal, then we have the end decimal number. That also will be part of rational numbers. For example, 0,5. 0,5 is is a rational number. Why? Because this can be written as 5 over 10. You know this. We can have, for example, and we can come back and for example simplify this fraction. So this is also a rational number. From the moment you have a number that each decimal has got an ending, then that number is also a rational number, right? We also have in irrational numbers square numbers. For example, let's have square root of 9. Yes, it's a rational number. Why? Because again, this number can be written as a fraction. We can say a square root of 9, okay, over 1, and we'll still have square root of 9, and the result is 3. And 3 again can be written as a fraction. Okay, as for example, if you write 3 as 3 over 1. So this is basically what we mean by, let's say, for example, these are perfect square numbers, like square number, square root of 4, which gives us 2, and 2 can be written as 2 over 1. So this is basically the definition of rational numbers. If a number is a whole number, then that number is a rational number. If a number is a decimal number, but it's a decimal number with an end, yes, it's also a rational number. Let's consider, for example, 7,3, 4, 5, 6, then it stops here, for example. Then this is a rational number. Different from irrational number. Irrational numbers are numbers that can't be written as fractions. Why? Because if you try to write it as a fraction, you still don't represent it in full or in total. For example, we have this. If I say 6,373 4 6 8, or even, and it still continues that way with no rule. First, it's a number. A rational number is a number that does not have an end, right? It's decimal continuous, right? It's there and it continues. You can keep on calculating it until tomorrow and you still have no final answer, no final decimal, position for it. And again, all square numbers that are not perfect. For example, we have square root of 2. Square root of 2, for example, is not perfect, and this is irrational number. Square root of 3 is not perfect, and this is a irrational number. Any irrational number. And square root, for example, of 4, no, you cannot put here. It should be here. Why? Because this square root here is now perfect. So let's come back and say square root of 5, and it goes like that. Square root of 7, square root of 8, you can't put it here. Square root of 9, for example, because it will give us 3, which is perfect. You can't. But square root of 10, square root of 11, square root of 20, you can't put square root of 36, for example, or 25, or 49. Why? Because those ones are now square root perfect square roots. So we have also another number that is, for example, pi. Pi, we know we only use the initials, like we usually use the first two decimals. We have 3,14, or 3 and 14, right? Hundredths in this case. So in this very specific case, also remember pi will be part of irrational numbers. Remember, irrational numbers are numbers that can't be written as fractions. Why? Because if you try to write it as a fraction, you can't represent it in full, in total. Why? Because each decimal form are endless. You keep on saying, you keep on going, and you keep on going, and you keep on going. There is another definition for irrational numbers, which is that they don't end, and they don't have a formula. There is no pattern. If you follow, for example, 3, this one in the calculator, you will see that this number here keeps on going and going, and you still don't see a pattern on the number. So if there is no pattern, and if it continues going like that and there is no pattern, naturally that is irrational number. Different from, for example, if I put here in irrational number, if you see, for example, a number which is, for example, 2, although it can be endless, 2,333333333. This number here, in this case, because it has got a pattern, you can see there is 3, it repeats 3, and because it repeats, this number, in this case, this one is rational. But if we had a number, for example, which is 2, let's say 3, 4, 5, 9, 7, 5, 6, 3, 0, 1, and you can see that there is no pattern here. If it said 2, 34, 34, 34, 34, and this is rational number. Why? Because there is a pattern. It follows a very specific pattern that we can notice. It's noticeable. But here, no, it is not. As if we followed this one, for example, we would see that all these results here are endless. Their decimal positions are actually endless. So in mathematics, I come with a very simple, structured and simple way in Tabara Academic channel. Don't forget to hit the subscription button and share with your friends who also might be struggling. And if you want more particular, more personalized private lessons, I will help you understanding all these concepts with with the less difficult, and you'll find it more enjoyable for yourself. So let's go. Come with me here for exercises, right? It's always what we do in mathematics. I do, we do, and you do. Let's go. In mathematics, we also have to come with exercises. So tell me in the comments, if this number, let's say for example, 24, is it, tell me in front here, is it rational or irrational? I would just want to see if this number is rational or irrational. B, tell me whether the numbers are rational or irrational. Tell me whether the numbers are rational or irrational. And D, you again tell me whether the number is rational or irrational. Don't forget to hit the subscription button and share with your friends and comment which school you belong, which grade you are, and which topic you find difficult, and I can happen to come back only for you. So finally you have this one, which is 3,0 600 60006. Oh, tell me whether this number is rational or irrational. All I want is that you tell me whether these numbers are rational or irrational. Thank you very much for watching this video. Don't forget to hit the subscription button and share with your friends and comment.